Welcome to the Iekkë tool demonstration. Iekkë is a new bounded model checking tool for multi-threaded C programs that use the pthreads API. Iekkë is built on top of the CBMC Deagle infrastructure and inherits the command line operation mode. It is called with a number of command line options, and the target file returns either a counterexample trace that shows a path to a property violation or a safe verdict if no bug is reachable within the given bounds. Let's look at the example on the right here. So this is a program that computes Fibonacci numbers in 2 threads. Each of them performs updates to shared variables, and the property that we want to check is that within the bounded number of updates, the Fibonacci number 21 is not reachable. So let's run Iekkë on this program. So as said, Iekkë takes the file name, I run it with the Minisat backend solver, and then there is a option rounds, which specifies the number of rounds in the bounded round partial order encoding. In particular, round 4 tells Iekkë to analyze only executions in which each thread gets to run at most 4 times. In addition, if necessary, we could use other options from CBMC, such as unwind trace. By default, Iekkë checks for assertion violations only, like the assertion here. Checks for other properties such as overflows or null pointer references can be selected using other CBMC options. So this property is obviously false. Let's see whether Iekkë can actually find that. And this goes pretty fast. So you see it's loading the program, it's performing symbolic execution, and then runs Minisat to solve the formula. And here it finds a property violation of this assertion. So we can add the CBMC's trace option to this and run again. And then it outputs the trace, the counterexample trace that leads to the property violation. So this counterexample trace is constructed using the models obtained from Minisat, and it essentially corresponds to one particular schedule of thread interleavings that leads to the bug. So we see here thread 1 is running, then thread 2 is running, thread 1 is running again, thread 2 is running again, thread 1 is running, and finally thread 2 is running again, and then the property is violated. Note that Iekkë, like all PMC tools, needs to be given sufficiently large bounds to find bugs. So if you call with a smaller bound, like let's say bound 3, then it says that there is no property violation found up to that bound. Iekkë uses a different encoding than CBMC, which results in smaller formula sizes because it's linear in the number of shared memory events rather than quadratic or cubic. So we can run CBMC on this program, and we see that it produces a formula with roughly 90,000 clauses. If we compare this to Iekkë again, let's run it. There we had only 60,000 clauses. Hence, it's also a bit faster, even on the small example. The effects are bigger on larger benchmarks, as our experiments show. So Iekkë can also be used to find data races. So if we take this Fibonacci example and remove the atomic blocks, we also remove the assertion at the end, then we can run with the data race option, and here it will find a data race violation. So this concludes our tool demonstration. By the way, Iekkë won the bronze medal in the concurrency category at SBComp this year. It was its first participation in the competition. For benchmark results and links for downloading the tool, have a look at our paper. Thank you.